The very first definition we have on this in this section is that of a variable. And we just talked about variables when we were going over our homework, so I know there's a background there. So our definition is pretty simple. It's a letter or a symbol used to represent an unknown value. Why do we call it a variable? The emphasis. Variable. Good, Jack. Yeah, it's tough to say, isn't it? Right. Yeah, the value can vary. That's the root of it. Vary, to change. So when we define a variable as one value, that doesn't mean that it's locked in. Like every x that you see is not going to have a value of 4 then from that point on. It changes. Within the same problem, it can change. And we're going to see one of those later on. So that's important to remember. The other thing is that for our sake, we're going to use a letter to represent variables. Specifically, we'll use lowercase letters to represent these variables. All right? Now, having said that, there are certain letters that we should attempt to avoid in order to not cause more confusion about what it's meant to represent, okay? So can you think of any potential pitfalls with certain lowercase letters when we do this? Leah? Yeah, so that's the thing. X is always the one we talk about first. So X, we have been, to this point, using X as a multiplication sign. Today's a big day for you guys. Today you've graduated from using X to represent multiplication. Now we're using X as a variable. X is probably the most commonly used variable, especially in algebra, X, Y, Z, all the time. So what we need to change, not that we're not going to use X anymore for a variable, but that we're not going to use X to represent multiplication. So we're graduating from more of that elementary approach. Now this is the more algebraic mindset, okay? So what do? If we don't want to use if we can't use the X anymore, we've seen this a bunch already. Amelia? Raised. Yeah, so the dot, right? The raised dot in between two numbers. That would work. What else? Some of us got caught on it on the bell ring. What else, Sarah? The parentheses, exactly. Okay, so there are other ways to do that. So X is good. What else might not be good? Or what might not be good? Finn? B? Yeah, but we use B for base all the time when we're talking, because the base can change when we get into geometry. So that's something we will use. Mikey? You said B, T. I like the O for sure. I'm writing that. Now you said T. Why? Exactly, okay? Now, depending on how you make your T, it might look like an addition sign. Now, if you're the people that make the T look like a plus sign, then avoid using the T in a case like that. Now, when I do a T, typically I do something like that, so it doesn't look like it. So I won't avoid using a T. Now, I will say this. 7th graders have an uncanny ability to make any letter look like just about anything possible, okay? I've seen it all. Someone will be like, don't use a C. I was sitting there like, why? They're like, it could look like a parenthesis. I'm like, I guess it could, all right? But I've seen C's look like, you know, 3s before, too. I mean, I've seen it all, okay? Some of the handwriting I've been exposed to over the years, it causes nightmares, okay? We're thinking of the more obvious ones. 0 and O look a lot alike. Think lowercase letters. Isaac? L. Why, Isaac? Looks like a 1. That's how I make my 1, right? I will put the T here, but I'll do it like that so that you can see if you're in that category, avoid. Quinn? Yeah. Yeah, exactly. D could look, well, again, it could look like anything. I do this all the time. I'll be looking at papers and I'll be sitting in a team room with the other teachers and I'll say, do you guys know what this letter or what this number is? And they look at it. They're saying, I get like 4 different answers from 4 different people. Yeah, that's a 3. No, it looks like 5. No, it looks like an X. That looks like a picture of, their dog. What is that? Right? We don't even know what that is. All right. So obviously these are ones that jump out. Do you have another one, Sarah? G, you said? Why? It could look like a 9. It could. I'm not going to write it because here's my assumption. I'm assuming that we're going to have very neat penmanship, okay? And looking around, I think several of us do. Some of you are probably going, not me, right? But these are the big ones, okay? All right, next thing. We've been talking about numeric expressions or numerical expressions. Today we talk about an algebraic expression. Now the difference between an algebraic expression and a numeric expression is now we incorporate variables. So it must contain at least one variable, and it must contain at least one math operation. I'm just going to scribble down some examples of algebraic expressions. There are an infinite number, of course, but since it has to have a variable and at least one operation, I could say something like n plus 3. 12 divided by x plus 9, something like this. So we said we're avoiding the x for multiplication. What if I wanted to put down 4 times n? We said the dot. Could I do it any other way, besides even the dot and the parentheses? Because 4 times n, we could say, yeah, that works. 4n, of course. So yeah, we can just do 4n, yeah. Multiplication is unique in that you do not need to have an operation symbol or notation in order for it to be assumed to be multiplication. So if I put 4n, then that's implying that means 4 times that number. I can't do that with other operations. So then the question always is, well, does the number always have to go before the variable? In a case like this, I would say yes, it should. There's a name for this number here. It's called the coefficient. You don't have to write that down. But yeah, we typically, if I'm avoiding using a symbol, then I put the number first. Okay? If I want to put the n first, then I should probably put the dot in between or something like that. Okay? Now I will be forgiving. So if you forget to use the dot for multiplication, if you use an x, like, yeah, I'm going to be forgiving on that early on. I'll probably just highlight it and show you that, hey, let's start working that out. I know old habits die hard, so it's going to take a little while, but we should go. All right? Any questions on what an expression looks like? Algebraic expression. Good. So you guys were writing it last night when you were doing that toothpick problem. That's what we were doing. All right. So the last part here. This is where we're going to stop after we get this part done. When I ask you to define a variable within a problem, I'm not asking you to write a definition for the variable. Like, a variable is a letter that takes the place of a number. Not that. Simply means when you define a variable, you pick a variable out and have it represent what's unknown in the problem. So I've given us a very basic problem here. Something for us to use just as an introduction. It talks about a student who earns $10 an hour babysitting. The hours will vary from week to week. It says define a variable and write an expression to find the amount the student earns each week babysitting. Well, in order for us to figure this total out, what important piece of information do we need to know? Brendan? You tailed off there. How many hours what? Exactly. How many hours did they work? How many hours did they babysit, right? So what information do you not know? I'll put Number of hours worked. Now, you don't have to write this every single time for these types of problems. This is just me outlining it. So we don't know what it is. We don't know the number of hours worked. And right there is your variable. Your variable always represents what you don't know. Right? Isn't that what a variable is? Unknown information. So when it says to define a variable, we want our variable to represent this information here. So suggestions on which variable we should use. Just an idea. Sarah? Yeah, I always try to make it appropriate. So H, we would say H equals hours worked. That's what defining a variable is right here. This step where you just tell me X equals, the number of pencils in the jar, or, Y equals the temperature that day, or whatever the variable is, okay? You always put that down. Now, what would our expression be? Using the variable, we're going to write an algebraic expression here. Zoe? 10 times H. That's it. I don't want an equal sign here. So don't put 10 times H equals another variable. No. All right? That would be considered an equation. We just want an expression. An expression does not contain an equal sign. So now when I find out what H is, when this student comes in and says, well, yeah, I worked 7.5 hours last week. All right. Plug it into that equation or expression. I worked 20 hours. Plug it in. I worked 2 hours. Plug it in. This changes every week. All right. So what about down here? $35 more than the number of tickets sold. How are we going to write an algebraic expression for that? Hayden, go ahead. Now, I can do that because I make my t like that. If you make a t a little differently, then maybe pick a different variable. And he did define it. He said t is the, I'll just put number of tickets. Yeah. Before everybody considered that hashtag. All right. That's actually the abbreviation for number. I use that a lot. Now, the next one, you don't have to define the variable because there's no context to the problem. The variable is just going to represent the number. Like, we don't know what the number is, so I always just use an n in a case like this. All right? So what would your expression look like? It's easy to make a mistake on this one if you're not careful. Good, Sam. She says 6 minus n plus 10. Is that what you said? All right, what do you guys think? People still have their hands in the air, so that must mean that we're not in full agreement. There is something wrong with that. Amelia, what do you think? 6, what was it again? I'm sorry. 6 times n minus 10. Did anybody have that? The difference of 6 times the number, so I'm writing that as 6n, or you could have done 6.n, and 10. The order matters. Remember we talked the other day about how subtraction is not commutative. You can't just reverse it. So since it said this part first and 10, there's your subtraction. Did anybody have it written differently that you think would work? Mikey? Okay, so you did this. Yep. Hayden? 6 plus 10 minus n. Well, we're not recognizing a key operation there with multiplication. So that one would not work. This one would work, this one would work, and that one would not. So tonight when you're doing these problems and it asks you to write an expression, I don't need to see the work that goes into it. This is just it. The only thing I would need to see is if you have to define the variable, just write me that one quick statement right there. Okay? That's all I would need. All right. That's it for now, guys.